I wanted to share with you the row code orchestrator CLI tool. It's a CLI tool built upon our row code ecosystem. Its main role and idea is to provide a sophisticated workflow orchestration by providing and coordinating between multiple AI personas. Basically, we have like 6 personas. We will talk about them later. All of that work together to build a high quality software development practices, which highly inspired by agile methodologies and trunk-based development and open source practices guideline. So this orchestrator CLI tool helps in 3 main parts. The first part is the memory bank system generation, which basically we have like a tool, or we are using tree setter, which build an AST tree for our code base or our source code, and then carefully craft like those 3 files, the project overview and technical architecture and developer guideline. And also we have like 6 personas. We have 4 main personas, which is the boomerang, architect, senior developer, and the code reviewer. We have supporting rules as well, which is the junior coder and junior tester and the researcher. All of those work together in a sophisticated workflow that also the CLI tool provide, and later on we will see with charts how all of those work together. The first chart we have here demonstrates the role relationship. So the execution workflow starts with single source of truth, which we have here is the memory bank and the 3 files we talked about. The first rule or persona, we call them in row code, as you know, mood. So the first mood we have is the boomerang. Take the task and go and make like an analysis based on the memory bank files and our source code, and it first try to like decide if we will need, or if we have like some missing information or something that will need a research or not. If it needs a research, it will call the researcher mode to create a research and gather information needed for this specific task, and then the researcher will pass the information to the boomerang, which will then continue to create the task description. And after we have the task description, it will pass it to the architect mode, which responsibility is about planning and creating an implementation plan with all the information and subtasks needed for the senior developer, which take each subtask and try to implement it with the helper modes we have for the senior, the junior coder and junior tester. From their name, like the junior coder is more focused into implementing or following the best practices the architect and the senior has gathered and added to the implementation plan, execute those subtasks, and after we finish the subtasks we have into the implementation plan, we report back to the architect, which then issue code review task to the code reviewer that ensure quality. And after all of those finishes, we go back to the boomerang again to update the memory bank files if we need to. The another part or important part I wanted to talk to you about is the context flow and token efficiency, because like when I have been working on this system, I faced a lot of issues regarding having to, like, each mode has to access the memory bank files and the code file and everything to be aware of the context and the task we are doing. But after lots of trial, I came to the fact that only the boomerang has to access the memory bank files, and it then creates a task description with all the information needed, which then started to be like treated as a single source of truth for the other rules we have. Like once the boomerang makes the task description, it then assign a task to the architect to make an implementation plan, and then it will goes down the road. And as we are going down, the context window is becoming smaller and smaller. So each rule we have, or each mode or persona we have, started to only deal with the context it has access to, which is narrowed down as we are going down the road. We will see an example very shortly that demonstrate all of this. As we were saying, everything starts with boomerang. So now we will see an practical example of how all of those modes work together. As I said, we are heavily inspired by trunk-based development and like open source contribution guideline, which means that like each task you are doing has to go into its own feature branch, and each commit you do has to have like clear message and retain like a structured workflow throughout the execution. Very important part we have inside the boomerang is that it creates like a task registry, As you can see here, we have the task name and also a notes, and also it creates if it needs like new tasks for the future that we already found or discovered while we are implementing the current task. And this helps a lot into like continue the same work. What I mean by this is that so now I can come here and ask it or say like what tasks we have that we should start on. And the first thing it will do, as we said, it should like look through the task registry and make sure that everything has a status is completed. And if we have like a note or a follow-up note or maybe a new task that it created, it will ask us to continue it. So as you can see here, first of all, it started by making sure or checking our registry, and it says that we have like tasks to address the LLM provider testing and also optimize project context structure. All of those are heavily related to the project we are working on, of course. Additionally, there is one task whose status might need an update, enhance memory bank generator content quality. And we have notes also. The notes mention blocked by issues in project context generation finding. And actually this task is finished, so it says that both of those tasks are completed. So this task should be marked as complete. And after this, it makes sure that it read the memory bank file to make sure it aware of the context and everything we have. So I will choose the next task. Actually, I delayed the test for our unit test for a bit to finish the tool quickly and also make sure that the business itself works as expected, and then we will continue on the unit test. So as I recall, the next task should be optimizing the project context, and actually this exact task addresses issues with a large code base so that it doesn't pollute the project context when we are generating the memory bank file. So the task that we should start on is of course optimize the project context structure. Now after I choose the task, it will go into our defined workflow, which start by reading the memory bank file and doing the researches. We will see all of this together. You see, it looks at the project overview to understand what we are doing and everything, so it become aware of what we have so far and what we have like regarding code architecture and best practice and all of that. It's very important that it goes through this thoroughly because like it is the only mode that actually looks through the source code and also our memory bank to make sure it generates sophisticated task description that will be like we will deal with it, or the other mode will deal with the task description as a single source of truth. So it has to contain all the information needed to get this task done, and also to reduce the token usage into reading the memory bank again when we move between one mode to the other. And because we are, as I said, heavily inspired by open source contribution guidelines and also trunk-based development, before it starts anything on the task, it wanted to know our get status to make sure that we start on a new branch. We should start with the new branch, and this is change we have in the system problem. Actually, there was a small typo or something that I fixed. So it starts with creating a new branch to start working. Then it will check our source code files to make sure it grasps everything it needs to create the task description. You see here it's correctly like figured out the issue I found, the duplication, which is the dependencies and div dependencies, peer dependencies, all of those are like cluttered and repeated across the project context. Actually, when I mean project context, it's internal object we use inside or when we create the AST tree that actually like parses our code source, like our source code to create the memory bank files. It's not related to the LLM or roocode agent project context. Okay, it grasps a lot of our information. Now it start to create a new folder for this task that will have the task description, implementation plan, and all of it. No worries, it started to use like sequential syncing. Okay, as you see fit. Now it started creating the task description. Let's have a quick look at it. All of those is so critical because that we don't want the architecture and all the subsequent rules or personas to start doing the same work again. So the boomerang has a look or has an overview about the task and every file it need to access, and create a sophisticated like task description as we are seeing here. And after it creates the task, it deliver it or pass it to the architect to create implementation plan with detailed subtasks. So it goes down the road to the execution, as we are going to see. This helps a lot in maintaining, let's say, a memory for like if I stop the task now, like try to start it again, it will have all the context it need. It will know that it created the task description, and it will know that the task is already in progress, so it should continue its execution. Now it should create a subtask to the arc. Actually, let's make this a bit bigger. Of course, one important thing is that we have like a verification step through each delegation we make. So the boomerang makes acceptance criteria for the architect, so that after all of the rules finishes their work, the boomerang will like test the execution of the task to the acceptance criteria it created here. The first thing the architect is going to do is reading the task description and looking through the files that is mentioned inside the task description, which is already filtered by the boomerang. After that, it starts immediately making the implementation plan with the detailed subtasks, as we are saying. Also, it defines its own acceptance criteria so that when it delivers the task to the senior developer and it gets the execution after the senior developer finishes, it makes sure that it like follows the acceptance criteria it defined. And as you can see, it makes like subtasks with detailed information about each subtask. So let's save this one. Now it will make a subtask to the senior developer with each subtask. And we will go now into a smaller workflow between the architect, the senior, and the two juniors until we finish the implementation plan. After we finish it, we will go to the code reviewer as we discussed earlier in this video. Now it makes a subtask to the senior developer, as we said, with only the first subtask. So we have the first subtask for the senior developer. It has a very important part, like let's say it's a recommendation for correctly follow the best practices. And I found that follows the best practices when the senior developer state or create the implementation plan and pass it to the junior developer. So now the senior developer only works with the implementation plan. It reads the first subtask. It will change its status to in progress and start making like very detailed subtasks to the junior developer and coordinate between each other until they finish the first subtask and then delegate it back to the architect. It is weird that it didn't delegate any task to the junior. Let's see why it did so. Actually, as I said, it's like recommendation, but if the task is small enough, the senior developer will go ahead and implement it as it has done now. It will make a commit for it. Now it finished the first subtask. It will include the completion report for the first subtask and deliver it to the architect. Now it made the task, the first subtask complete, and also like if it need to add any note or something, it added to the implementation plan. So at the very end, the boomerang will scan all the notes and everything and start like decide if we need like a follow-up node or a follow-up task or something like that. Now the architect have received the completion report. It will make a quick verification as we discussed to make sure that the implementation goes as planned, and after it verifies everything, it will go to implement the second subtask. Maybe this subtask will contain some work that the senior developer will actually delegate to the senior. To the junior. Now it try to make a subtask for the junior, and actually you can stop it in any time if you need something or if you need to change something or make sure that it follows something in your head. You can stop it and like deal with it very easily. I think this task is becoming, sorry, this method is becoming very big, and it should like make it smaller. Now that the junior coder has finished, the senior will make sure that the junior has done the task assigned to it correctly and make sure that it reviews it extensively and then assign another subtask. So I want you to consider like or reimagine if we have one, like if we only have the senior developer now, it will have to do all of those changes, and for one or two of them it will of course miss something here and there. But having this delegation between the senior and the junior, it makes sure that everything goes as and also because it has a specified implementation detail for the junior, it makes sure that it follows a good architecture and adhere to our code. Actually, this file is becoming too big. I will create small task to the junior developer to start like moving some of those methods into another file so it doesn't exceed like 400 line or something. So it makes easy to like work with this file afterwards. So actually, I can ask it to do so now. Most of the time it push back for some changes like this, but hopefully it will like asks me like to address the concern about project analyzer becoming too large. I propose moving the file tagging logic to a new helper. My plan is create a new file directory, node implement a new class. Okay, yeah, do so. Okay, the file is still a bit big but acceptable for now. We'll have to fix those typing issues. Okay. You see this, guys? Excellent work. Junior coder created a dedicating directory node trigger service as a great architectural choice and makes the project analyzer cleaner. The implementation looks solid. Now the architect will make sure that subtask 2 is already done, and we will go back and forth. Actually, I will try to make the video short to be in point, but so far you get the point. Like we have the sequence going as we expected. Now subtask number 3 is going to be assigned to the senior developer, and for the testing, as I told the senior developer that we will delay the test so that the architect is already aware of that, and when it say about testing requirement, it says it's differed for another task to focus on actually making the like business. And actually this is only for this project, but in your project, if you want to make the tests and all of this which is recommended, you can do so. Okay, guys, now we have reached to the last task we have. So it's basically running the generator manually to make sure that it generates the correct project context and adhere to the changes we have done so far. Once we have that subtask finished, we should like continue with the bigger picture. After the senior developer finishes this task, it should delegate it back to the architect, and then it should delegate it to the code reviewer and back to the boomerang. Looks like we have some test issues. I think it better to ask the senior to like delegate this subtasks to the junior tester, so we don't pollute this task context, because I wanted to be focused on the manual testing on. Did actually like a workaround by disabling the test from the compiler issue. Sorry, the compiler configuration and test config, so that it can run the build successfully and continue test. For this task, that's fine. Now it should have finished, so we'll review the files. Before it was about like 8,000 line, now it's 5,000, so a big reduction, which is good. So now I'm just like trying to finish the task so that we can complete the other parts of our workflow. I know it's a deviation from the plan, but that's what I want. But actually, I maybe ask the architect to make sure that it tells, or maybe directly to the boomerang, so it can like create a task for making sure that we are not strictly tied to like tsconfig and package.json and make the CLI tool more dynamic with other languages and source code file. So the senior developer now is marking the last subtask in our implementation plan as complete, and it's doing the last commit. When the junior tester were trying the build command, it failed. So it changed the tsconfig so that it can bypass the test file and exclude them from the build. But now the senior developer is saying that we have this concern. Let's see what they will do about it. Now the architect is reviewing the work that's done, and now verification of change. The senior developer did mention temporary add-in and execute array to allow the application to build by skipping test file type checking. This change matches are reported and was done to unlock manual CLI testing because the messages submitted are deferred for the changes. Okay. Now all of our task has been done, so we are doing now a code review task to basically go through all the changes and make sure that we don't have any issues. Like based on the nature of the task we have done, we already had a task for the tester to manually test the application. So I think this last step about the code review is not that critical. Anyway, we can do it. Maybe could figure out something or came up with something that need to be fixed. So going through file by file and making sure that it's following our best practices and everything. Not all the files of the repository, but the files that we have touched through this execution should create a report, but most of the time the OpenAI models doesn't follow this and they don't create document. But I think the architect will make a redelegation. Let's see what will happen. So they should have created, or the code reviewer should have created a document mentioning all of the code review finding and everything. But so far it didn't create anything. So figured it out and should redelegate a task for them to update. Mostly the boomerang is the one who is checking the code review report. So if it doesn't find it, ask the architect again to create it. Now that the boomerang has everything, you should update the memory bank file to reflect the changes we have done on this task and make sure that we have the task registry and everything up to date. Is that it will update the technical architecture to reflect the changes we have done. After all of this, it makes as a completion report, and also it should mention like if we have any notes or follow-up. As you can see here, like testing is called differ, and this is a very important part as well. Learning and outcomes and follow-up actions makes this task as completed now. But you can see the follow-up refactor project minimal structure manual for testing critical follow-up automated tests deferred test config file. Now we'll make a final like push for this branch because like we are using the trunk-based development, which means that after we finish the feature branch, we should push it and make a pull request for reviewing, actual reviewing in GitHub and all of that. Proceed with the push. We don't have something to do. Okay, thanks.